This is day one of my interview preparation. For the next 30 days, I am focusing on building strong fundamentals, clear thinking, and consistent preparation. This is not about promises or just timelines, this is about showing up and doing the work every single day. Hi, I'm Mily, and I'm documenting this series starting January 1st, honestly, without shortcuts, one day at a time. I have several years of experience in the tech industry, but interviews don't reward experience alone. They reward clarity, how clear you think and explain, and how structured your approach is. Even when we know concepts, we often fail to communicate them under pressure. The series is my way of rebuilding that clarity from ground up. For day one, I'm intentionally keeping things simple, so I'm starting with array fundamentals. Not because they are easy, but because every interview problem builds on them. So today's focus is correctness and explanation, not speed and optimization. Now that I've set the context, let me start with the problem solving part and walk through the fundamentals step by step. Let's start with the first problem, finding the maximum element. Here the array contains the elements 2, 7, 11 and 15. I begin by assuming that the first element is the maximum, so the current maximum is 2. As I traverse the array, I compare each element with the current maximum. When I say 7, it is greater than 2, so I update the maximum to 7. Then I compare 11 and update the maximum again. Finally, I compare 15 and update the maximum again to 15. So the logic here is very straightforward. I assume the first element is the maximum, traverse the array once, and update the maximum whenever I find a larger value. This solution runs O of n times. As I scan the array once, it uses O of one extra space because I only track a single variable. Let's move on to the next problem, checking whether an array is sorted. In this example, the array contains 1, 3, 5 and 4. I compare each element with the element that comes immediately after it. 1 is less than 3, so the order is correct. 3 is less than 5, so that is also correct. But when I compare 5 and 4, the sorted order breaks. At this point, I can immediately stop and returns false. There is no need to check the remaining elements. The key idea here is early exit. I stop as soon as the condition fails instead of checking the entire array blindly. In the worst case, it still takes O of n time and the space complexity remains O of 1. Now let's look at the two-sum problem using the brute force approach. I start by fixing the first element in the array and then I add every element that comes after it with the fixed element and compare it with the target. So here 2 plus 7 equals 9, which matches the target. So I found a valid pair. This approach uses two nested loops to explore all possible pairs. I started the second loop from the next index to avoid using the same element twice and to prevent duplicate checks. The time complexity is O of n square, as we are using two loops to explore all the possible pairs, and the space complexity remains O of 1. Now that the logic is clear, I'll translate this directly into code. I'll start with the function to find the maximum element. Here, I've fixed the maximum number with the first element of the array. And then I iterate through the array and compare current element with the maximum number. And whenever we find any current element greater than the maximum number is updated to the current element and then return the maximum element. Here I handle the edge case of an empty array first. It returns none if the array is empty. So let me run this code again. So here 15 is the largest element in this array, so it has returned 15. Next, for checking if the array is sorted, I compare each element with the next element, and if the order breaks, I immediately return false and run this. It returns true as this array is sorted. Finally, for twosome, start the inner loop from the next index to avoid duplicate pairs. summing up the two elements and matching it with the target. If it matches with the target, I return the indices of those two elements. Let me run this code. Here it returned 1 and 3. So the element at first index is 3 and the element at third index is 34. Sum of these two is 37, which is the given target. So today I'm just covering the brute force approach for 2-sum. I'll continue with the optimized approach tomorrow. One realization from day one is that it's easy to rush mentally and jump straight to the final answer. But interviews don't reward rushing. They reward structured thinking even for the smaller problems. The key learning today was keeping the scope small, focusing on just a few problems and explaining them well. Tomorrow I'll continue with arrays and go deeper into time and space complexity. If you're also preparing for interviews, feel free to follow along. This is 30 days of honest preparation, no shortcuts. I'll see you on day 2. Keep learning.